Hey, my name is Riglet Goyle, and this is my Lab1 report. This lab is all about observing electric fields and how those electric fields influence objects and their surroundings. To set up this lab, I first stuck a piece of base tape that was around 20 centimeters in length to a desk with a small handle that would allow me to peel the tape on and off. And then I took several subsequent pieces of U-tape that were around the same length and stuck them on top of the base tape and then peeled them off using the handle to give them an electric charge. I then took these pieces of U-tape and held them near surrounding objects such as my finger or a charged pen or even another piece of U-tape to see how they would interact. Throughout the lab, I made several observations. When I charged two pieces of U-tape, for example, I predicted that they would repel each other given that they would most likely have the same charge, and I was correct, as when I hung these two pieces of U-tape near each other, they repelled each other. Inversely, when I took a piece of U-tape and hung it near a charged pen, I found that the pen actually attracted the tape. And since the pen had been negatively charged using my hair and using my shirt, I determined that the U-tape had to have a positive charge, since in order for two objects that were charged to be attracted to each other, they had to have opposing charges. Finally, I took a piece of U-tape, which I labeled tape B, and attached it to two books and allowed it to be lifted over my desk. Meanwhile, I charged another piece of tape, which I labeled to be tape A, and slid it underneath tape B, so that tape A and tape B would create an electric field that would push each other, and tape B would be repelled upwards, while it was also being subject to gravitational force. And here was some data that I collected from this experiment. First, I took the mass of tape B and multiplied it by gravitational acceleration to see what type of gravitational force tape B was being subject to. And I found that this gravitational force was 1.962 e to the negative 3 Newton. I then took this gravitational force and set it equal to electric force. When I had slid tape A under tape B, I found that tape B was pushed upwards by a very slight distance, approximately 0.005 meters or half of a centimeter. I then took this distance and plugged it into the aforementioned electric force equation. When I solved this equation out, I found that charge was equal to 2.33 e to the negative 9 coulombs. This charge is supposed to represent the charge that tape A and tape B approximately have, and we are going off the assumption that tape A and tape B have the same charge. I then took this charge and divided it by the charge of a single electron, where I got 1.46 e to the 10. This number is supposed to represent the electron deficiency. I then took the area of that piece of tape, and I found the approximate area of an atom. When I divided these two values, I got a value of 4 e to the 17th, which is supposed to represent approximately the amount of atoms that were supposed to be on that piece of tape. Lastly, I calculated a ratio of the electron deficiency to the atoms, which came out to around 3.65 e to the negative 8. For the code, I created two spheres and two arrows, which represent the single point charges which represent the charge of tape A and tape B, as well as the two forces being exerted on tape B respectively. I then used the difference of the positions of tape A and tape B to acquire an R vector, from which I calculated an R magnitude, which is represented as R mag in the code. Afterwards, I used the tape mass to calculate the gravitational force on tape B, which was then used to determine what the electrical force on tape B would have to be in order for it to float. I then used this force and the R magnitude variable from earlier to determine what the charge of the tapes would have to be. Here, you can see that it comes out to around 2.33452 e to the negative 9, which is approximately what I had in my own calculations. Some key assumptions that we're making here. 1. I'm ignoring air resistance on both pieces of tape, which could seriously change these calculations. I treat each long tape as if it was a single point charge represented by these two spheres. And third, I assumed that both pieces of U-tape had about the same amount of charge evenly distributed amongst the tape. To wrap things up, here are some additional questions. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? Here's my answer. Instead of having an electron deficiency, the tape would actually have an electron surplus, since more electrons would be needed to give the piece of tape a positive charge. Secondly, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? My response is, my hands and other objects can ground some of the charge that these U-tapes contain, and would therefore not make the attraction and repulsion strong enough to observe. For example, in the last experiment, where I took tape B and tape A and tried to repel them from each other, the distance that tape B was repelled was incredibly minuscule. And if I would have grounded some of the charge that would have been in either tape B or tape A, I might not have been able to observe a distance at all.